Hey everybody, it's Miss Berry. In this video we're covering section 1.3, which is called Coordinate Geometry and Introduction to Circles. Alright, so a couple of formulas that we're going to need. We have our midpoint formulas here. We've got two different versions of the midpoint formula. How you're going to know which one to use is depending on what type of problem you have. So if you are trying to find the midpoint of two coordinates on a number line, then you're going to use the top formula. Right, so if you are, say, given, find the midpoint between -2 and 10. Right, so that would be two numbers that are on the number line. And you can see here the description of the formula. It's just the average or the mean of the coordinates. So you just add them together and then divide by 2. So if you're given the line AB, the line segment, I should say, given the line segment AB on a number line, the coordinate of the midpoint M of the line segment AB is midpoint equals first coordinate plus second coordinate divided by 2. And since you're adding these, it does not matter what you choose to be A and what you choose to be B, but you know, if you're going to stick with the notation here, then little a would be the coordinate of the endpoint on the left, and little b would be the coordinate of the endpoint on the right. All right, so midpoint gets the symbol capital M in this class. That's not always the case. Sometimes in certain algebra books they don't give midpoint a symbol. You just have to write out the word endpoint. But in this class we're going to use capital M to represent our midpoint. All right, and then the bottom formula here, so looking down here, this is the midpoint formula if you're given the coordinates of 2 points. So if you're given 2 points x, y on a number line, or excuse me, on a plane, then the coordinate of the midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. All right, so you just add the x's together, divide by 2. Add the y's together, divide by 2. So you're really just doing the average of the x's and the average of the y's. All right, so let's take a look at how we're going to be using this formula, what the problems are going to look like. All right, so let's start off with an easy problem. It says find the midpoint M of the line segment PQ. All right, so here we've got our line segment, we've got, we've got our number line, then we've got our line segment, which is in gold here, and then we've got this labeled, the point on the left here is P, and the point on the right is Q. All right, so let's grab those numbers. -3, P is -3, Q is 5. All right, so to find the midpoint of that line segment, we're just going to add those together and divide by 2. All right, so the formula is little a plus little b over 2, where a and b are the end points of our line segment. All right, so that's -3 plus 5 over 2. -3 plus 5 would be the same thing as 5 minus 3, so that's 2 over 2, which is 1. All right, so the midpoint is 1. All right, so increasing in difficulty slightly here, it says find the midpoint of the line segment PQ that joins the points P, which is the point -3, 3, and Q, which is the point 1, 0. All right, so we're going to grab our midpoint formula for points. All right, so we have our point x1, y1, x2, y2. I always like to label those, get that out of the way first thing. Even if you feel like you can keep them straight in your head without labeling them, I want to strongly encourage you to label those each time. It just saves you from making a simple mistake. All right, so there's our formula. Capital M equals x1 plus x2 over 2, and then y1 plus y2 over 2. All right, so the average of the x is the average of the y's. All right, so let's grab our x values. Our x1 value is -3. x2 value is 1. All Our y1 value is 3. Our y2 value is 0. All right, so negative 3 plus 1 over 2, 3 plus 0 over 2. All right, so now let's simplify. Negative 3 plus 1 would be negative 2. So negative 2 over 2. And then 3 plus 0 would be 3. So 3 over 2. All right, so negative 3 plus 1 we said was negative 2. Negative 2 over 2 is negative 1. And then 3 over 2 does not reduce. That is in simplest form, so we're just going to leave it as 3 over 2. I would be fine if you wrote that as, you know, what would that be, 1.5? Yeah, so if you wrote 1.5 instead of 3 over 2, I would be fine with that. All right, so once again, increasing in difficulty. This time it says the midpoint of the line segment CD is M, which is the point negative 2, 1. So they're telling you the midpoint. One endpoint of that line segment is C, which is the point negative 5, 7. What are the coordinates of the other endpoint, D? All right, so they told you the midpoint and they told you one of the endpoints, and you're supposed to find the other endpoint. All right, so let's grab our formula for the midpoint. That's what we see. We see this word midpoint in the problem. We have a formula for midpoint. So that's sort of the key word there that's telling me which formula to use. Sorry, I'm trying to grab my highlighter here and it won't let me. There we go. All right, so that word there, midpoint, is sort of our indicator of how are we supposed to proceed here. All right, so we're going to proceed by using the midpoint formula, and let's just go ahead and plug in everything that we are given. All right, so everything that we're given. All right, so the first thing that we're given is the coordinates of the midpoint. So they told us that M is negative 2, 1. All right, and then the second thing that they told us is that one of the endpoints, we could say that's x1, y1, is negative 5, 7. Right, so imagine that we are taking this away here. Let's see if I can get this to work. Oh, wow, that's not working for me. All right, so imagine that we've taken this away here. Just ignore that. Okay. All right, there we go. All right, so just ignore that over there. Now we're setting this whole formula equal to negative 2, 1 because they told us that that is the midpoint. All right, so this is the midpoint formula, and this is the midpoint. All right, so this is equal to this. All right, then we also know one of the endpoints. All right, so let's replace x1 and y1 with negative 5 and 7. All right, now this is going to create two equations. This is going to create two separate equations. All right, so we're going to start with solving for x2. It doesn't matter which one you solve first. You could solve for y2 first. It doesn't matter. But we're going to start with x2. Just do it in order. All right, so we've got our coordinate, our x coordinate of our midpoint equal to our x coordinate of our midpoint. All right, so let's grab those two pieces, set them equal to each other. All right, so we've got negative 5 plus x2 over 2 equals negative 2. All right, so we've got to solve for x2. We need to get x2 by itself. All right, so the first thing that's standing in our way is this 2 in the denominator. All right, so let's get rid of that. How would we get rid of this 2 in the denominator? You would multiply both sides by 2. Right, so multiply both sides by 2. That's going to cancel out that 2 in the denominator. It's going to leave you with negative 5 plus x2 in the top. And then on the right-hand side, negative 2 times 2 is negative 4. All right, great. Now this is something we can easily solve. we just need to move this -5 over, get x2 by itself. All right, so we're going to add 5 to both sides to get x2 by itself. Right, so if you add 5 to both sides, -4 plus 5 is +1. All right, great. So we've got our x-coordinate of our endpoint. Now let's go back to our little formula and get our second equation. All right, so here's where we were just working from. We just took the x-coordinate and set it equal to -2. Now we're going to do the y-coordinate, so 7 plus y2 over 2, and set it equal to the y-coordinate, which is 1. All right, so take the y-coordinate, set it equal to the y-coordinate. So there we go. We're going to take the same approach here. We're trying to get y2 by itself. That 2 is in the denominator is in our way right now, so we can easily get rid of that by multiplying by 2 on both sides. Right, that's going to cancel out the 2's on the left. 1 times 2 is 2. Now we are going to subtract 7 from both sides to get y2 by itself. So if you subtract 7 from both sides, 2 minus 7 is -5. And there's our y-coordinate. So we just put those two pieces together, our x-coordinate and our y-coordinate, and then we have the coordinates of the other endpoint. All right, so the coordinates of the other endpoint, 1 comma -5. 1 comma -5. I do like this one for the test. I think it's kind of a creative way to utilize the midpoint formula. It just sort of is, you know, testing your algebra skills as well as, you know, testing your geometry skills. So I do like this one for the test. So put a little star by it. All right, our distance formulas. All right, those were midpoint formulas. Now we're looking at distance formulas. So again, we've got two versions of the distance formulas. All right, so we've got the distance formula if you're on a number line. This formula is super easy. It just says take the absolute value of one of the endpoints minus the other endpoint. All right, so it says if A is the value x1, B is x2, then the distance between points A and B is the absolute value of x2 minus x1. And remember, absolute value makes things positive. All right, so for example, if you had something like the absolute value of, -3 plus 2. Right, -3, you work inside the absolute value, simplify that first. All right, that's important. All right, so simplify inside the absolute values first. All right, so -3 plus 2 is -1. Absolute value of -1 is just +1. All right, and then similarly, if you had something like the absolute value of 5 minus 2. All right, so work inside the absolute value, simplify that first. 5 minus 2 is 3. The absolute value of 3, well, 3 is already positive, so nothing changes. It's just 3. All right, and then on the coordinate plane, you probably recognize this distance formula. I'm sure you've used it in the past in one of your, maybe an algebra class or in some geometry class in high school. All right, so the distance between 2 points A, which is the point x1, y1, and B, which is the point x2, y2, is given by this formula. They're using little d to represent the distance, so lowercase d. So lowercase d, the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. This is definitely something that you would want to put on your formula sheet. This is kind of, you know, a complicated formula. It'd be super easy to accidentally, you know, put a minus here in the middle instead of a plus. So make sure you're putting these formulas on your formula sheet, or, you know, just keeping a running list of all the formulas that we've used in this unit, and that way when it comes time to make your formula sheet, you have, you know, a big list right there for, you know, ready for you to use. All right, so let's use some of these formulas. Let me show you how they're used. All right, so we're starting with the harder one this time. It says find the distance between the points P and Q. P is the point -3, 3, and Q is the point 1, 0. And then it says give an exact distance. So that's going to be like where we leave it in the radical, or we simplify the radical. Sometimes you'll end up with a perfect square, like square root of 16, and that'll be, work out easily. But sometimes you might end up with something like square root of 15 that doesn't, isn't a perfect square, doesn't simplify. All right, so we're supposed to give an exact distance as well as a 1 decimal approximation. All right, so we're going to need our calculator on this one. So if you haven't gotten your calculator out yet, now would be the time to pause the video and grab that. All right, so here is our distance formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, let's label our points. x1, y1, x2, y2. Now we're just plugging them in. All right, so starting here, x2 is 1, so 1 minus -3 squared plus, parentheses, y2 is 0, so 0 minus 3 parentheses squared. All right, so let's plug everything in. That's what we're working with. Remember your order of operations here. All right, so we are starting inside the parentheses. All right, go ahead and change that double negative to a positive. All right, now simplify inside the parentheses. 1 plus 3 is 4. All right, so right here, 1 plus 3 is 4. Then over here, 0 minus 3 is -3. All right, so 4 squared plus -3 squared. All right, 4 squared, that's 4 times 4, which is 16. -3 squared, that's -3 times -3, which is 9. All right, so square root of 16 plus 9. 16 plus 9 is 25. Square root of 25, that's a perfect square. 25 is a perfect square because 5 times 5 is 25. All right, so the square root of 25 is 5. All right, so we didn't have to worry about doing a 1 decimal approximation here because this turned out to be a perfect square. So we're in the clear. All right, now here's one that's a little bit easier. Remember, this is where you do the absolute value. So you subtract the two coordinates and then take the absolute value. All right, so find the distance between the points P and Q. P is the point -3. Q is the point 5. Right, so there's the formula for the distance between 2 points on a number line. All right, we're going to grab those values. That's 5 minus -3, x2 minus x1. So I'm using the endpoint on the right as x2, the endpoint on the left as x1. So 5 minus -3. Simplify inside of the absolute values. 5 minus -3. We change that double negative to a positive. 5 plus 3 is 8. The absolute value of 8 is just 8. Right, so the distance between points P and Q is 8. Now you could also find this just by counting. So if you start here on the number line, you can say 1, 2, 3, 4, 5, 6, 7, 8. All right, so if you drew the number line out and it's a short distance away like this, you can just count. That's fine. All right, so now we're moving on to the circle portion of today's lesson. Couple of things to know about circles, some circle review. If you're in a plane, a circle is defined as the set of all points equidistant from a given point called the center. Equidistant means equal distant, right? So all of the points on the circle are the same distance from the center. The diameter of a circle is the segment that goes all the way across the circle. All right, so let's say this is our circle. Diameter is the line segment, that goes all the way across. All right, so it says it's the segment that contains the center of the circle. That'd be right there in the middle. Right there, let's say in the middle. And it has both endpoints on the circle. So you've got this endpoint on the left is on the circle, the endpoint on the right is on the circle. And the length of that line segment is also called the diameter. Right, so the line itself is called the diameter, and the length of the line is called the diameter. All right, the next one is the radius. The radius is where you take the center of the circle and you're going to draw a line out to the circle there. All right, so it's really half. So the radius is half of the diameter. So it's just the diameter divided by 2. So it's the segment, the radius is the segment that has one endpoint on the circle. All right, so one of the endpoints is out here on the circle. Excuse me, let me read that again. The radius is a segment that has one endpoint at the center and the other endpoint on the circle. And the length of that segment is also called the radius. All right, so the segment itself is called the radius as well as its length. All right, and then lastly, if you have two circles and you're told that they are congruent, then you can assume that those circles have the same radius. All right, so the plural of radius is radii. All right, so if you are told that you have two congruent circles, you can assume that they have the same radius and the same diameter. All right, a couple more vocabulary words. A central angle is an angle whose vertex is the center of the circle. That's what we're going to be working with here, central angles. If you're told any kind of information about the semicircle, then I need you to know that that is exactly half of a circle. All right, so it could be the top half. It could be the bottom half. Could be the right half. The left half. All right, so a semicircle is just exactly half of a circle. A minor arc is going to be smaller than a semicircle. A major arc is going to be larger than a semicircle. All right, and then one last thing that you do need to know. A circle, if you start here and you were to travel all the way around the circle, that circle contains 360 degrees. All right, so if you're to look at the semicircle, exactly half of that, this half down here is 180 degrees. This half up here is also 180 degrees. All right, so a semicircle is half of a circle, so it is 180 degrees as the measure, 180 degrees. All right, here's our arc length formula. We're not going to use this for a few more slides, but I'm going to go ahead and talk about it briefly. It says the length of an arc of a circle is given by the following formula. Now let me tell you what an arc is. Here's a circle. Think of the circle as like a pizza. An arc of a circle is like the crust of the pizza. All right, so the arc is like this little piece here. Let me see if I can highlight that. So you can think of the arc as being like the crust of the pizza. All right, so the length of an arc of a circle is given by this formula. So the length of the arc or the pizza crust, the length of the pizza crust is equal to the measure of the arc over 360. So what portion of the whole circle is it taken up? So the measure of the arc over 360 times the circumference of the circle. Now, I want you to dust off the cobwebs. Look back in your mind. See if you can remember the formula for the circumference of a circle. What is the formula for the circumference of a circle? C equals, did you say pi r squared? That's wrong. It's not pi r squared. It's 2 pi r. Do y'all remember that? All right, so the circumference of the circle is C equals 2 pi r. So we are going to need to use that formula as well. All right, so we've got the length of the arc is equal to the measure of the arc over 360. That's just going to tell you what portion of the circle is this taken up. How big of a slice of pizza are you working with here? Times the circumference of the circle. So what size is the pizza? Is it a small pizza, a medium pizza, or a large pizza? Okay, So here we have an example. Sorry for the quality of this picture. It's not very good quality, but I did redo it for the homework, so the one on the homework has better quality. All right, so it says answer parts A through C about the circle O. I'm not sure why they would name the circle O. That seems like a terrible name for a circle. I just want to briefly mention that this symbol here, it's like a circle with a little dot in the middle. That just means circle. All right, so if you see that symbol, that just means they're about to name a circle. Right, they're about to give a circle a special name. All right, so we're supposed to answer parts A through C about the circle O, and they told us that the radius of the circle is 18 centimeters. All right, so we're going to use that in a little bit when we go to find the arc length. All right, so first part says find the measure of BE. All right, so find the measure of the arc BE, not the length, not the arc length, but the measure of the angle within the arc BE. All right, so let's look at BE. Here's B, here's E, so let's just draw a line connecting those. Right now we are going to add up the angles in there. So we've got 35 degrees, we're missing this, and 30 degrees. All right, so that's a problem. We're missing a big chunk. We don't know how big this is. You could probably guess. You could say like, well, you know, this is 35. It definitely looks bigger than that. This is 45. Can't tell if it's bigger or smaller. All right, so we're going to have to do a little bit of investigation to figure out what angle that is. All right, so let's forget about BE for a second. We do know some information about a semicircle. We know that a semicircle is equal to 180 degrees. So let's try to see if AF, that's the chunk that we're missing, can we look at it as part of a semicircle? We can. It's right there. AF is part of that larger semicircle. We know that this is 90 degrees. We know this is 30 degrees. So maybe we can use the fact that we know these two angles. We know that this whole green angle here is 180. All right, so we can use those three pieces of information to figure out what the measure of AF is. All right, so that's a semicircle. It has measure 180 degrees. All right, so it says the angle DE plus the angle EF plus the angle FA, all that is equal to 180 if you add those up. All right, so let's replace the angles that we know. Right, we know that DE, the measure of the angle DE is 90, and we know that the measure of the angle EF is 30. All right, so DE is 90, EF is 30. All right, so 90 plus 30 is 120. We don't know FA, that's what we're trying to figure out. All right, so let's subtract 120 from both sides to get the measure of angle FA by itself. Subtract 120, that gives you 60. So FA is equal to 60. All right, so now let's go back to the problem that we were supposed to originally solve. What is the measure of BE? BE, let's just add up all the angles that are contained within that pizza crust. All right, so 35 plus 60 plus 30, which is 125. All right, so the measure of BE is 125. All right, now find the measure of the arc AED. AED. Well, we just did that. That was 180. All right, so easy peasy. All right, now here we have the arc length problem. Find the length of, all right, so when you see that word length, I want to think arc length. All right, so we said that the formula for the arc length is the measure of the arc divided by 360 multiplied by the circumference of the circle, which is 2 pi r. All right, so DEF, let's draw that, highlight that. All right, so there we go, DEF. All right, so that's 90 plus 30. All right, so let's figure that out. 90 plus 30 is 120. 120 over 360. The degree symbols cancel. When you have units that are the same on the top and the bottom, they cancel each other out. if you had like centimeters over centimeters, that would cancel centimeters out. Similar situation here, degrees over degrees cancels degrees out. All right, so 120 over 360 is 1/3. All right, so it's 1/3 of the pizza. Now let's find the circumference of the circle. Remember that formula is 2 pi r. They told us at the beginning that the radius of that circle is 18 centimeters, so just plug in 18 for r. 2 pi times 18. I'm just going to leave that in terms of pi. That way I don't have any rounding mistakes, since I'm just plugging this in as part of a larger piece, or as a chunk of a larger formula. So I'm going to leave that as 36 pi. Hopefully you saw where that 36 came from. That's 2 times 18 is 36. So just combined sort of the numbers. All right, so let's take each of our little chunks. Remember the measure of the angle divided by 360, that was 1/3. And then the circumference of the circle is 36 pi. So now we're gonna plug this whole thing into the calculator. So 1/3 times 36 pi. 1/3 times 36 is 12. And that's centimeters. Why is it centimeters? Because they gave us centimeters in the original problem. This would be the exact answer. So if you were supposed to give the exact answer, you would say 12 pi. If you were supposed to give an approximation, you would plug it in the calculator. You would say, okay, 12 times pi is 37.699, which rounds to 70, so 37.70 centimeters. I want to say that I did a decimal approximation on the homework, but don't quote me on that. So that would be the approximation. Both of them are correct. It just would depend on how the question asked you to give your answer, right? So the exact answer was 12 pi centimeters. The approximation is 37.70 centimeters. All right, got a couple of really easy questions here. Just like looking at what you're given, looking at what they're asking for, and seeing how those things are related. All right, so it says in the circle O, the measure of CA is equal to 100. I think I missed my little arc there. That should have had a little arc over it. All right, so the measure of the arc CA is 100 degrees, and AB is congruent to CD. I'm pretty sure we've talked about this symbol before. Pretty sure we've talked about this symbol before, but just in case, that symbol means congruent. All right, so it says also the center of the circle, point O, is the intersection of the line segment CB and the line segment AD. All right, so O is right there in between. So it's halfway in between C and B, halfway in between A and D. And we're asked, what is the measure of angle 3? There's angle 3 right there. Well, we were given that the measure of the arc of CA is 100 degrees. All right, so that chunk of the pizza, think of this as like a piece of pizza. So here's the crust. Whoop, sorry, that went off the rails a little bit. Let me try that again. All right, so there's our piece of pizza. Once again, went off the rails. Oh my goodness, just got worse. Okay, so they told us that that piece of pizza is 100 degrees. Well, that's the same thing as the angle 3, that they're in the same spot. So angle 3 is 100 degrees. Super simple. All right, now we have what is the measure of DB. Here's DB over here. Well, if CA was 100 degrees, these are vertical angles. So that means the measure of angle 4, or the measure of angle of the arc DB, must also be 100 degrees. Angle CA, or the arc CA and the arc DB, those are vertical angles. They're, you know, the pieces of pizza are equal in size. All right, our last topic, working with the equation of a circle. I like these problems. You're definitely going to see 1 or 2 of these on the test. says the equation of a circle with center HK and radius R is expressed by this equation here. X minus h squared plus y minus k squared equals r squared. All right, so again, x and y, those are just points that are on the circle. H and k are, that's the center of the circle, and then r is the radius of the circle. All right, so what is the standard equation of the circle with the center 5, -2 and the radius 7? All right, so really straightforward. You're just going to take your equation of your circle and you're going to plug in what you know. All right, we were given that the center is 5, -2, that's h and k, and the radius is 7, so that's r. So let's plug everything in. All right, so we have x minus 5 squared plus y minus -2 squared equals 7 squared. All right, so just plugged in h, k, and r. X and y I left alone. All right, so as far as how much of this do I want you, how far do I want you to go with this? You could, kind of go around in a circle here. If you multiply all this out and then try to solve for x and y, you're going to kind of get back to the same spot. So let's talk about how far you need to go here. I do want you to take any double negatives and make those into positives. All right, so take any double negatives, make those into positives if that's, necessary in your problem. Sometimes you may not have a double negative. And then I also want you to take that right-hand side and then just simplify that. So 7 squared is 49. All right, and that's all I want you to do. So I want you to just, simplify any double negatives and then simplify the right-hand side. That's really all I'm asking you to do as far as simplifying here. So let me just make a note of that. So simplify double negatives. And then simplify okay, the right hand side. Not sure if this will come up again, but just so you know, right hand side in math, we typically abbreviate that as RHS. And then you could probably guess left hand side would be LHS. Right, so right hand side we abbreviate that RHS. Left hand side we do LHS. All right, so that's all I want you to do here as far as simplifying on the test. And of course it'll be multiple choice. So that'll probably, give you an idea of what your answer should look like as well. All right, so here, this is probably the most challenging problem that we have on today's notes. It says, what is the standard equation of the circle with the center 1, -3 that passes through the point 2, 2? So you're not given the radius. All right, so we're given the center, which is HK. All right, so we're given HK, but we're not given R. We're given another point circle. All right, so we need to find the radius. Now there's a complicated way that you can do this, which was my original approach. I was thinking, okay, well, we'll plot these 2 points. We'll plot the point 1, -3. Then we'll plot the point 2, 2 on the coordinate plane, and then we'll find the distance between those 2 points. All right, so that was my thought. And then once we knew the distance between those 2 points, then that would give us the radius, right? Because this is the center of the circle, this is a point on the circle, so we heard the definition of the radius earlier. That was the line segment that connects the center of the circle with a point on the circle. But there's actually a much easier way to find the radius of the circle, which is just to plug in what you know. All right, so let me show you my initial approach, and then I'll show you the easier way to do it. All right, so this is what I was thinking. I was thinking, okay, well, here's the circle. The center is at 1, -3. 2, 2 is a point on the circle. So you would plot those 2 points and then maybe just sketch a circle. Here I used Desmos. I don't know if y'all ever heard of that. Desmos. I used Desmos to generate the graph. really nice free tool. It's pretty intuitive as far as, you know, you don't need to know like a lot of programming or anything to use it. All right, so then I was thinking, okay, I'm going to use the distance formula. I'm going to connect those two, then I'm going to use the distance formula to find that distance, which is that formula, as you probably remember from earlier in the video. But there's actually a much easier way to do that. That takes several slides of algebra. There's a much easier way to do this, which is just to say, okay, well, I know the center, and then I know this point 2, 2, which I can call xy. That's just a point that's on the circle. All right, so I'm going to take x, replace it with 2. H, replace it with 1. Y gets replaced with 2. K gets replaced with -3. I don't know what r is, so I'm just going to leave that as r squared. All right, so here we go. Let's plug this stuff in. All right, so x minus h, that becomes 2 minus 1. Y minus k becomes 2 minus -3. All right, so there we go. All right, so 2 minus 1 squared plus 2 minus -3 squared equals r squared. Remember, we're just leaving r squared alone. Now let's go ahead and change that double negative to a positive, and then add those together. 2 minus 1 is 1. 2 plus 3 is 5. All right, so we have 1 squared plus 5 squared. 1 squared is 1. 5 squared is 25. All right, so r squared is 26. Now, don't worry about getting r by itself. We don't need r by itself. We needed to know what r squared was, so let's just leave that alone. All right, so let's put it all together. There's our formula. We know that h and k is the center of the circle. That's 1, -3. We know that r squared is 26. So there we go. X minus 1 squared plus y minus -3 squared equals 26. Go ahead and change that double negative to a positive, and you're done. That's it. That's the equation of the circle. All right, hopefully that gave you a good overview of this section. If you do have any questions that I haven't answered, please send me an email, and I will get back to you as soon as I can. I'll see you in the next video.